Okay, so here is the extra example from does most go along with your checkpoint? So slide 9, using trig to find missing values. So what is the measurement of AB? So if we look at the picture, segment AB is this one right here. And we can tell that that's the hypotenuse because it's across from the right angle. So I'm just going to go ahead and label it as the hypotenuse. So when you're doing a problem like this, or like this problem, slide 8, we covered in class, you want to start off by figuring out what you have and what you are trying to find. So we of course are trying to find the hypotenuse. So I'm going to label that also with just an X because it's a variable that we're going to solve for. And then we know this angle right here, 52 degrees, angle A. And then we want to figure out what side AC is, because that's the other side that we know. We don't know BC, and we don't want to know BC. It doesn't ask about BC. So we need to figure out what side AC is in terms of is it opposite or is it adjacent? It's not hypotenuse because we already know that's AB. So side AC is the leg, which means it's not a hypotenuse. So it's a leg that helps create angle A. So since it helps create angle A, it forms part of it, that's the adjacent side. And if you're ever not sure, you can still, if it's helpful, you can label the opposite side if you want to. So side BC is technically the opposite side because it's across from angle 52. So if labeling the opposite side before the adjacent side is helpful, you can. We just don't need to use it in this case. So for this problem, we have the 52-degree angle. We know the side that's adjacent to it, it's 10, and then we want to know the hypotenuse, which is AB. So we want to pick the trig ratio that combines adjacent with hypotenuse. So it would go back to our list of formulas. So if we find the one that combines adjacent with hypotenuse, it's cosine. So when we set up our equation, we'll be using cosine. So we'll say cosine of our angle, and usually, or not usually, but in the previous problems we had cosine of C or cosine of A, and those are the actual angles. But in this case, we know what the angle measurement is. We know it's 52 degrees, so we'd say cosine of 52 degrees, and you could put the degree symbol if you want, or you can leave it off. It doesn't really matter because it won't be a part of your final answer. Cosine of 52 degrees, and then just a reminder, the cosine formula is adjacent over hypotenuse. So when we write the other side of the equation, so we'd say cosine of 52 equals, and then over here is going to be the adjacent over hypotenuse, but we're going to put in the actual values. So the adjacent side is 10, and then the hypotenuse, that's what we're trying to solve for, so we'll put an X there. Or if you want to use AB, you can use AB, that's fine. So our setup is cosine of 52 degrees equals 10 from the adjacent side over X from the hypotenuse. And then you'll see for these problems, they give you decimal approximations for the different trig ratios for the angle that is given. So sine, cosine, and tangent of 52 degrees. They do this to avoid calculator mistakes. So you'll see pretty much all of the problems that require you to set up like this will offer you these. And so we want to use them. So it's saying that, cosine of 52 degrees is approximately 0.616, says it right here. So we're going to take that 0.616 and we're going to put it into the equation where cosine of 52 degrees is. So cosine of 52 degrees, and so that'll do 0.0616, and then equals 10 over X. So on the problem for slide 8, we had a setup that looked like this, except for our variable was in the numerator. So when that's the case, it's a little bit easier version of this problem. It's a little bit trickier, meaning there's one added step when the variable ends up in the denominator, and there's not really anything you can do to control that. It's just the way that the problem works out. And how this case, we wanted to find the hypotenuse, and the hypotenuse is in the denominator. On slide 8, we wanted to find the opposite side, and the opposite was in the numerator. So it's just kind of how the problem works specifically. So When I have the variable in the denominator I'm trying to solve for, I have to get it out of the denominator. So I have to cancel it out. So again, think of this as like 10 divided by x. So if I want to think about canceling out division, the opposite of division is multiplication. So I would multiply both sides by x. So multiply by x on the right side of the equal sign, and then I have to multiply by x over here as well. So I'll multiply both sides by x. And then these are going to cancel out, which is what I want. These two I'm going to have to multiply together, and since I don't know what x is, I'm just going to have to write it kind of as we would anytime we multiply a constant by a variable. So I do the like number part first, the constant, 0.616x. So x times 0.616, I would write as 0.616x, and then equals, over here, the 10 is all that's left because the multiplying by x and the dividing by x cancel out. And then our ultimate goal is to get x by itself. So now I want to figure out, okay, I have 0.616 that's being multiplied by x. So to cancel out multiplication, I need to divide both sides by 0.616. So multiply both sides by 0.616. And then multiplying and dividing, those are going to cancel each other out. So the 0.616x divided by 0.616 is just going to leave me with x after those cancel. And then just grab a calculator if you want, and just do 10 divided by 0.616. And that leaves me with approximately 16.23 if I round to the nearest hundredth. So remember that x is the variable that we used to represent segment AB. We could have used AB if you want to. I just like to put a variable there instead. But that 16.23 is equal to x. X is what we use for AB, so length of AB is approximately 16.23. You just always want to make sure too that it kind of makes sense in context. Like in this case, we're trying to find the hypotenuse. We know the hypotenuse is the longest side of the triangle. We know that one of the other sides of the triangle, one of the legs is 10. So my answer needed to be longer than 10. So that 16.23 does make sense. It's not smaller than 10. It's not crazy long compared to the 10. So contextually makes sense as well.